Okay, these are your answers for section 10.1 in the grade 9 math links. This is on circle geometry. And 10.1 is basically just about the idea of a central angle and its relationship to inscribed angles. So in the first question, we have in the diagram angle BDA, which is right BDA. So start with the B. Oh, I got my marker here. Start with the B, go to your D, and go to your A. This angle right here is angle BDA. Measures half of angle BCA, which is right here. Does the rule for inscribed angles hold true for BEA, which is right here? Explain your reasoning. Well, the answer for the relationship between this is actually a central angle because 2 points are connected to the middle of a circle, and those 2 points are connected to a point outside of the arc. But this is an arc that connects point A and point B. And we cannot create inscribed angles by connecting a point to something inside the arc. In order for the relationship between central angle and inscribed angle to be true, it has to be created on any point outside of the arc, not inside the arc. So the answer for that is no, it doesn't hold true because the inscribed point is within the arc, which makes it not inscribed or not holding true to the central angle inscribed angle relationship. Question 2 says Manny constructed a circle using a compass. He used a straight edge to draw a diameter. So he drew a circle. He used a straight edge to draw a diameter. Then he constructed an inscribed angle and shared endpoints with the diameter. So he drew something over here and shared endpoints. What is the measure of the inscribed angle? How do you know? Well, if he drew a straight line will have 180 degrees in it. And I could show you that by taking, I think I have a compass here somewhere. Where's my compasses? Right here. Oh, this was not it? Oh, this was not made. Well, I'll do it anyway because I'm already here. So take my compass, bring this over here, put it on there. My straight line is not really straight, so it's going to be a little bit wonky, but we get the idea. You put it straight on there, and that is, if I look here at 0, as I go around, oh, you can't see it on the video probably, all the way down to here, it gives 180 degrees of view. So a straight line actually has 180 degrees of view. And since this is 180 degrees of view, this is 180, which would be the central angle. And when those 2 points are connected to a point on the circumference, it will form inscribed, which is half of 180, and it would be 90. Question 3 says, what are the measures of angle ADB? So again, start with your A, go to your D, and then your B. So what is the measures of this? And what is the measures of AEB? Well, A and B are connected to the middle, which makes this 82-degree angle the central angle. And when A and B are connected to any point outside of the arc, this is your arc here, as long as the points are outside of there, they will be inscribed, which means that both this point and this point are inscribed to 82, which means that both angles are going to be 41 degrees, which is half of the central angle. Okay, and I could draw another one over here, and when I connect those 2 points, this will also be 41. So we could put one here, those will also be 41, and so on and so forth. So anytime I connect A and B to any point outside of the arc, I will create an inscribed angle, which is going to be half the measure of the central angle. Question 4. Do we have to do 4? Okay. What is the measure of angle FJG? So F to J to G. What is the measure of this angle right here? Explain your reasoning. Well, F and G are connected to the middle, okay, which makes this a central angle that we don't know. F and G are also connected to H, which makes FHG an inscribed angle of 23 degrees. So with that knowledge, I know that this angle right here would be the central, and it would be 46 degrees. And F and G are connected to another point J, just like F and G were connected to H. So this is inscribed to the central angle that we didn't know. It would also make it 23 degrees, right, half of the central. And if I put a point up here and connected F and G to that, that would also be 23 degrees. Question 5, do we have to do that one? We did. So it says, draw a circle with a central angle that measures 60 degrees. So I'm actually going to do this properly. I'll actually do this with the proper tools here. Hopefully I can do it. I'm going to draw a little dot there first. And I'm going to take my circle tool. And I'm going to make a circle, roughly like that. And I'm going to take a radius, and I'm going to, oh, that's not a radius. I'm going to take a line, and I'm going to connect that to there, making a radius. Okay. Then I'm going to take my compass, which is right here. I'm going to drag that down onto my dot. And I'm going to see that right here, it starts at 0. And right here is 10 and 20. And what I'm going to do is I'm going to find 60 degrees, and I'm going to put a dot right there. So right up there, no, right there would be 60 degrees. If I go in from there, I can see where the 60 degrees is. I'm going to take away my compass. I'm going to close it. I think I can close it. I can delete it. And what I'm going to do is I'm going to connect that center point to that line there, and I've made a 60-degree angle. So then what I'm going to do is I'm going to put a point A and a point B there, A and B. And I'm going to draw 2 inscribed angles. So I'm going to put we'll put a C here. I'm going to connect those 2 there. And I'm going to put a D down here. I'm going to connect those 2 angles there. And it doesn't matter where you put them. And both of those measures are going to be 30 degrees. And I know that because A and B is connected to the middle, forming a central angle. And A and B is connected to these other 2 points that would form inscribed angles, half the measure of the central. And I could actually measure them. I suppose I can grab my compass again. And just to see if it's close, grab my compass and rotate it like this. Put it on the little point there. Keep rotating it until it gets there. And, well, it's not quite perfect. It's actually closer to 32 degrees or 35 degrees, but that's only because, well, there's 2 reasons why. I didn't use a ruler, and I stink at drawing straight lines. But you get the idea. Question 6 says point C is the center of the circle. There it is right there. The diameter AD is 17 centimeters. Chord BD is 15 centimeters. What is the measure of angle ABD? Well, again, if AD is the diameter, that makes this angle 180 degrees. And since A and D are connected to B, that makes it half of the measure, or an inscribed angle of 90 degrees. What you're supposed to then do is, once you see that this shape here is actually a right triangle. So if you take it and rotate it, put your little fancy symbol in there to show it's 90 degrees. Put 17, which is your hypotenuse, and 15, which is here, and X, which is here. This chord length, the chord length AB, would actually be one of the legs of a right triangle. So what I'm going to do is simply draw squares onto my right triangle. 15 squared is 225. 17 squared is 289. 289 take away 25 is 40, 50, 60, 64. And if the area of the square attached to that chord AB is 64, then the side length must be the square root of that, which makes chord length AB 8 centimeters long, or the square root of 64. Question 7. The circle has a center C and a radius of 8 centimeters. And angle FEG is 45 degrees. So what is the measure of FCG? So since F and G are connected to a point outside of the central angle, we know that that is a inscribed angle of 45, which makes F and G connected to the middle a 90-degree angle. Okay? And it says, what is the length of chord FG? So the first thing I'm going to do is redraw my right triangle. Right? F would be here and G would be here. And the center point C would be here. And we know that this here, FC, is 8 centimeters, right? But it's also a radius of the circle, which it doesn't say that, but this here is also the radius of a circle, which means it's also going to be 8. And that's a tricky thing. You have to realize that FC is a radius and so is CG. So I got to put 8 and 8 down, 8 centimeters here and 8 centimeters here. And this distance here is really the chord that it's asking me for. So it's the hypotenuse of a right equilateral or isosceles triangle, excuse me. Put down your squares. This would have an area of 64. This would have an area of 64. This would have an area of 128. So therefore, the measure of the chord would be the square root of 128, or approximately 11.2 maybe, 11.3. So therefore, what is the measure of the chord? Is approximately 11.3 centimeters long according to Pythagoras. Question 10 says in the diagram, C is the center of the circle, and angle ABD is 38 degrees. So if angle ABD is 38 degrees, for each of the following questions justify your answer. What is the measure of ACD? Well, ACD would be the central angle to the inscribed of 38, which makes this angle twice the inscribed, or 76 degrees. 76 degrees, okay? The next question says, I'll just put 76 in here. What type of triangle is triangle ACD? And the answer for that is triangle ACD is a isosceles triangle. And the reason why it's isosceles is because this distance here and this distance here are both radiuses, which means they're of equal measure. So when I redraw this triangle, I could really do this for my redrawing, right? And then the last thing says, what is the measure of the angle CAD? So what is this measure? And question 10 is really asking you, do you understand the properties of an isosceles triangle? And do you understand what the sum of three angles in a triangle equals? So the first thing you have to know is all three angles will always add up to be 180 degrees. But if it's an isosceles triangle, the base angles will always be the same measure. Now, since we know this to be 76, if I subtract 76 degrees from this, I get 104. That means the remaining two angles have to equal 104. And since they're equal in measure, because it's an isosceles triangle, each of these has to be 52 degrees. Okay, 52 plus 76 would give me the 180 degrees. All three interior angles of a triangle will equal. So that's how we figure out this would be 52, and this here would be 52 as well. Question 11 says point C is the center of a circle, and CFE, so CFE is 20 degrees. Okay, 25 degrees. Justify each of your answers for the following questions. What is the measure of ECF? What is the measure of this? Okay, well, the first thing I'm going to do is I'm going to take this triangle right here, and I'm going to redraw it right down here, and I'm going to rotate it. Rotate it. And if I look at this triangle, I'm going to put my little circle thing here. I know this is a radius and this is a radius, so I'm going to put those little marks there. And what we have here is this triangle is an isosceles triangle. This one we know to be 25 degrees. So the question is saying, how many is this one? Well, in order to do that, I first have to realize that because it's an isosceles triangle, this is also 25 degrees, because this is a radius and this is a radius, the two legs of it. So this one has to be the remainder of the 180, and since these two add up to be 50, 50 plus 130 degrees is the 180 for the interior angles of a triangle, and therefore this would be 130 degrees. Step 1. Step 2 says, what is the measure of EGF? So what is the measure of this? Well, now that I know this to be 130, F and E are connected to the middle for 130. F and E are connected to this to make an inscribed angle. So this angle here would be half of 130, which is 65 degrees. So therefore, angle EGF is 65 degrees. Question 12. If KJM is 15 degrees, right here, KJM is 15 degrees, and point C is the center of the circle, what is the measure of each of the following angles? What is the measure of KLM? So what is the measure of this? Well, these 2 points are not connected to the middle. But if they were, it would form a central angle. And I'll just do it anyway. And I don't care what that angle is. It's something. I have no idea. No idea what the degrees are. But it doesn't matter, because those 2 points are connected to over here, forming an inscribed angle to a central angle that doesn't exist, making it 15 degrees. And because those 2 points are connected over here, That's an inscribed angle to a central angle that doesn't exist, and would therefore also be 15 degrees. So the answer for KLM is 15 degrees. Okay, so I can put that in there. The next thing says, what is the measure of JKL? So JKL, I'm going to erase this now. JKL, where's my J? JKL, what is the measure of that? Well, J and K and L. So J and L are connected to K with a mystery degree, but J and L are also connected to 24. So if J and L are connected to make 24 degrees, any point that J and L are connected to are also going to make a 24 degree angle, which makes JKL 24 degrees because it's an inscribed angle to 2 points J and L to a central angle that doesn't exist. Next one, JCL. So if I go JCL, now we have a central angle, okay? And now we have a central angle that J and L were connected to make 24. And since JCL is now a new thing that we just drew, it's going to be twice the inscribed, which makes it 48 degrees, because J and L are connected to M to make 24. So J and L connected to the middle would be twice that, or 48 degrees. And finally, KCM, the central angle that now exists. Since K and M were connected there to make 15, when K and M are connected to the middle, it would be a central angle, which is going to be twice the measure, or 30 degrees. Question 13. In the diagram, angle BAD equals 30 degrees, 34 degrees. So BAD right here, 34 degrees. And angle ADE, which is ADE right here, is 56 degrees. What is the measure of ABE? ABE. So the first thing I have to look at, well, A and E right here. A and E are connected to B, and A and E are also connected to D. So because A and E are connected to B and A and E are connected to D, they're going to be the same degree. So right here, it forms a 56 degree angle over here, which means this too will be 56 degrees. And if I just do that with a different, I'm going to draw out a different circle, A and E here. There's A and E. When it's connected to B, it forms 56 degrees. When it's connected to D, it will also be the same 56 degrees. Okay? So now we have that angle, ABE, being 56 degrees. I'll take these points away here. And once we know that, this is what's the measure of AGB, which is right here. Now, in order to get that third angle, we have to remember the rule that all three angles in a triangle add up to be 180 degrees. So since this angle and this angle are 34 and 56, I'm going to add those two together to get 90. Okay, so the two angles that I do know in the triangle add up to be 90, which means the other angle, the one I don't know, also has to be 90. So I know that this measure is going to be 90 degrees. I'll put 56 degrees here. With that known, what type of triangle is ABG? And the answer for that is it's a right triangle because it contains a 90-degree angle. And what is the measure of DGE? So DGE, what is this angle right here where the dot is? Well, when two lines intersect, this angle and this angle will be the same measure. And this angle and this angle will be the same measure. So since these two lines are intersecting, try and erase that again. Since these two lines are intersecting and this is 90, the one across from it also has to be 90 degrees. So question 14 says, after looking at the diagram of the circle, Amanda decides to use the Pythagorean relationship to calculate the length of chord AB. Will this method work? Explain. Well, it won't work, and here's why it won't work. In order for the Pythagorean relationship to work, you need a 90-degree angle. And even though that ACB looks like it's 90 degrees, it's actually 110 degrees. And we know that because the inscribed angle to A and B is 55, so A and B connected to the middle will be central at 110. And this is a two radiuses here and here, which means that the rest of it has to split 70 degrees, which would make this 35 degrees and this 35 degrees. And the Pythagorean relationship will not work on triangles that don't have a 90-degree angle. Question 15. Find the unknown angle measures x and y in each diagram. Explain your reasoning. Okay. So the first thing is I'm going to just put an imaginary point here and here, and I'm going to call this A, and I'm going to call this B. So A and B are connected to this point over here, which we'll call it C. Why not? There is no central angle, but A and B are connected to C and make an X angle. All right. So the first thing we have to do is figure out how many degrees X is, and we don't need to know anything about inscribed or central, because if I have a line and I have two angles, I have an X here and a 135 here, I know that this straight line is 180 degrees. So we call these supplementary angles. 135 plus the degrees in X have to total the 180 degrees of the straight line. So if I take my straight line 180, subtract the angle that I know, I'm going to get 45 degrees. So therefore, X has to be 45 degrees to complete the straight line. So the answer for X is 45 degrees. And going back to my AB connected to C, if that is 45 degrees, because they're connected here, and those same A to B points are connected to Y, then AB is or angle X of 45 degrees is an ascribed angle to a central angle that doesn't exist. And A and B connected to any other point, including Y, will create that same inscribed angle, which means Y is also 45 degrees. And again, I can connect A and B to this point over here. That would be 45 degrees. A and B to this point, and that would be 45 degrees as well. Question B. It says, what is X, what is Y? So again, we have this point and this point here, which are connected to the middle. We'll call it A and B. And we have this point and this point here connected to X. Well, the first thing we have to see is this triangle right here. And I'm going to redraw it over here. Okay? And this side and this side and this side are all equal in measure. Now this is called an equilateral triangle. And equilateral triangles share the property where every angle is of equal measure. So the sides are equal in length and the angles are all 60, which means X is going to be 60 degrees. That's the first thing you had to see from the information given, is that X will be 60 degrees because there's an equilateral triangle. So I'm going to just put 60 degrees here. And this point and this point, we'll call it A and B, are connected to this point C. But A and B are also connected to the middle to make Y a central angle to the inscribed angle of 60, which means Y is going to be twice the measure, or 120 degrees, because it's a central angle to a 60 degrees inscribed angle. The next question, question C, all it gives you is 15 degrees, and it says, what are the measure of the other ones? So the first thing I'm going to do is I'm going to take this triangle right here, and I'm going to redraw it over here. Something like this, okay? And this is 15 degrees. Now, because this is a radius, and because this is a radius, I can put these two lines on here, and I've now identified that triangle that I've drawn to be a isosceles triangle, which makes this 15 degrees, and would make this one 150 degrees. And I know that because 15 plus 15 is 30. 30 plus 150 is 180. So I'm going to put right here, this angle right here, to be 150 degrees. Okay? Now that's not part of the question, but Y is. Okay? So if I draw this line here, up here, and I put my point here, and I put my ray, and I say this is 150 degrees. Because this is a straight line, the two angles, 150 and Y, have to add up to be 180 degrees. So Y, the right here, has to be 30 degrees. So the first question, Y is 130, or is 30 degrees, because it's supplementary to the angle of 150. Okay? Now X, let's see if I can get this. Okay, X is easy. So if I take these 2 points here, and I connect it to, actually we could have done that a different way too. Oops, doesn't matter. If I connect it to this, So that is an ascribed angle to 15. I suppose it would have been much easier to say that those 2 points when connected to the middle will make a central angle, and y will be 30 degrees, which we knew already through a completely different pathway. But when those 2 points are connected to x, they are still supplementary to the central angle and will still be 15 degrees. Okay? And if I connected those 2 points to this, that would be 15, and those 2 points to that, also 15 degrees. Boy, I did that much more complicated this way, but it was more fun. Okay, so the next question, question D. I'm going to put a point here and a point here, and I'm going to connect those 2 points together. And that is going to be the diameter of the circle, right? We can assume that that's the diameter of the circle, which is 180 degrees. When those 2 points are connected to here, that is going to make this 90 degrees. Okay? When 2 points on a diameter are connected to any point on the circumference of a circle, it was going to make a 90-degree angle. So if I redraw this triangle, I have an isosceles triangle that has 90 degrees. So both of these angles here are going to be equal in measure because that's the rule of isosceles triangles, the base angles. So each of these has to be 45 degrees. So y is 45 degrees. Okay. Now, so again, same rule again for the other triangle. I have 2 points. So this one here, when it's connected to there, will make a 90-degree angle. Okay. And if this is 90 degrees and this is 55 degrees, 90 degrees plus the 55 degrees that I know of the one angle is going to be 5 and 14, 145. And since all 3 angles inside a triangle have to equal 180, I'll take the 180 and subtract the 145 to tell me that x has to be the remaining angle, which is 35 degrees.